Hola amigos! Welcome to the second video in this fireworks VFX tutorial. Today we'll continue right where we left it last time and add some trails to our rocket. We will also replace that ugly white ball, no offense to Destiny's Traveler, with a much nicer rocket particle effect. Let's get started. As a bit of a recap, this is where we ended last time. We created this fireworks launcher system using two blueprints, a fireworks launcher and a fireworks rocket. It has a good amount of configurable parameters, but those are all for the general behavior of the launcher. And in terms of the visual quality, it's not very interesting yet. The last thing we did was use one of the default templates that Niagara comes with, this explosion, just to have a little something to show. So let me stop this and let's open our fireworks rocket first. Let me bring it here. And the first thing that we're going to do is add a few new parameters. I'm going to start by selecting the collider and searching for visible and unchecking that. Now let's create four variables. For the rocket itself, first we want a boolean, and we can call this one rocket visible. Next, let's do a texture to the so rocket sprite, and search for texture to the and object reference. Next we want a color, so rocket color, and let's make this one a linear color. And finally, I think maybe rocket scale, to be able to scale this sprite without scaling the rest of the trail or the other effects. And let's make this one a float. Now we want to make all these four visible, but also expose them on spawn. The last one. Now we can organize this a little bit. So maybe the rocket lifespan can go on rocket settings, and this can be on explosion settings. We'll add more to that later. And then try trail settings, and then we can move all the others to rocket settings. Now it's a bit more organized. Let's compile and save, and let's bring our fireworks launcher now so we can pass those properties when we configure them. See, this didn't refresh, so let's compile and go back, compile and save, and now it's here. So now let's duplicate all these properties, and maybe we can put in rocket settings here. So let's do rocket visible, rocket sprite, scale, and rocket color. And this one is a linear color, this one is a float, this one is a texture to the reference, and this one is a boolean. And we can now make all these ones public, compile, and give them some default values. So normally we want our rockets probably to be visible by default. And let me bring, I got a few flares that I use on a different tutorial. I'll post a link to these ones as well, but it's the same file. So I'm using this one for now. And scale by default should be 1, and rocket color, let's make this bright pink. 1, and value, let's give this maybe 25. And there we go. Perfect. Now we can compile and save, and let's use all these values now. Actually, let's add one more linear color and call this one rocket end color, and then I'm going to rename the first one rocket start color. Now we need to add this one as well, and also this one is public here, and then let's also add it on our fireworks rocket. So rocket and color, make this one a linear color, and then we can move it here. We can probably also order this a little bit. Yeah, like that. Okay, so I just added another linear color, call it rocket end color, and then rename the first one rocket start color, and added it both in the fireworks rocket and in the fireworks launcher. Oh, why is not? Oh, there they are. Now we can connect everything. Let's connect first the visible, scale, sprite. Oh, and both colors. Now, to show the rocket, we could simply just attach a sprite and do some fancy material editing to modulate the color or something like that. But let's do it with a Niagara system instead. So let's go to the fireworks rocket, and we're going to attach a Niagara system. So select Niagara particle system component and keep it attached to the collider. So we can call this one rocket or Niagara rocket. Now we need to create a system to attach here. So let's create also a new folder. Call this one Niagara. And inside here, let's create a new system and select new system from selected emitters. And just let's select the empty emitter, click the plus icon to add it, and click finish. And then we can call this one Niagara system rocket. Let's open it up and see what we have here. Now, all those variables that we created on both the launcher and the rocket will need to be passed to this Niagara system. So before we add any new modules to this emitter, let's create some user parameters. We won't need the visibility, because if we don't want to have a visible rocket, we can just disable the entire system in the blueprint. So let's do a float for the sprite, the rocket sprite scale. For this one, we cannot use the name sprite scale because that's already being used. And let's create two linear colors. We can call this one a start color, and the second one end color. Now we need to pass also the texture, so create a new texture, and this one will be the sprite texture. And finally, we need to pass the lifespan, so create a new float, and we can call this one lifespan. Oh, there we go. Perfect. Now we can compile and save and give some default values to all of these. So lifespan, let's say 2 seconds. And start color, let's make it again a bright pink. Oh. and end color maybe a bright orange or red or something. Yeah. Yeah, I like that. And let's set default scale to 1 and select the same flare that I had outside. Now first we want to change the emitter state and have its own life cycle determined here on the emitter, and we can actually rename this one to maybe rocket. Now let's assign the lifespan. Let's drag it from the user parameters section to this loop duration and change the loop behavior to once. So this particle will last for this duration and then we'll play once and that's it. Now on the emitter update, let's add a new module and let's select spawn burst instantaneous. And we only need one particle, spawn at 0. And there it is. We have one particle that stays there for, by default, 5 seconds, but let's change also this lifetime to be equal to the lifespan. So let's just drag it here and drop it on the lifetime. Now color mode can be left to unset because we're going to change the color over time on the particle update. So let's add a new color module here. And here we are going to search for lerp and select the lerp linear colors. And now we can grab our start color and drop it on the start color input, and the same for the end color. Now for the lerp factor, let's do a float from curve. And let's select by default the first ramp. Now this will make our particle last for 2 seconds, and in those 2 seconds will change from bright pink to bright orange. Now the reason I added a curve is because maybe you want your particle not to have a constant gradient between two colors, but just change at the very end, for example. So we could do that by manipulating this curve. So we can just drag the first one to, let's say, half of its life. So it stays half of its life as a bright pink, and maybe it changes to the bright orange before it dies. Do something like that. Oh. So the change is a bit less gradual, or you can use any of the presets. And now let's scale this color. So let's add another module to the particle update and search for a scale color. Now the reason is because first we're setting just the color, the RGB of the particle, and here we're going to scale it so it fades over time. So we don't need to change the RGB, so we can disable that. But we need to change this color value to scale from particles initial color to particles color. So search for color, and at the bottom of the list, just select this particles color. And now if you play it, nothing seems to change, except that we can now change this scale alpha for a float from curve. And maybe we can change it to be a smooth ramp down. So now our rocket disappears. Perfect. Now let's also scale that. So we have our sprite scale. So on the initialized particle, we can try to find a good default value. Let's say our sprite size mode, instead of unset, let's change it to uniform. You can also change it to random, uniform, or non-random, or non-uniform, or random non-uniform, but for now I'll just keep this, and let's say we want 25 units, but let's actually multiply this float. So 25 units times our rocket sprite scale. So we know that 1 is a default value, and if someone wants to make the rocket twice as big, doesn't need to remember that 25 is a good size. So it just sets a 2 on the scale. Excellent. Now we need to do something about this material because right now it's using the default sprite material. So we'll need to create something to replace this one. Before we create this new material though, there's an issue here. You see, I created this user parameter sprite texture as a texture 2D, but we don't really need that. You see, when you use textures in Niagara, like that, it's usually as part of a sample texture module that you might use later to drive the behavior of the particles in one or another way. So here we don't need that, so we can get rid of this parameter and create instead a material interface. So search for material and add a material interface, and we can call this one sprite material for instance. Now we can still not add it here, but here under the material on the sprite renderer module we have this material user parameter binding. So click on that one and select the user parameter that we just created. And now we're ready to create this material. So save this, and in the content browser let's create a new folder for this material. I'll call it materials and create a new one, and we can call this one material rocket. Now on the general properties, let's make this one, keep this as surface, let's make it additive and change it to unlit. Now we also want it to be two-sided, and if we use search for Niagara, we want to use this with Niagara sprites. Perfect, so all the setup there is done. Now let's bring our particle color, and we also need a texture sample, and we'll need a texture parameter. So texture object parameter, and we can call this one particle texture. Now let's change this default value for our flare, and let's connect this to our texture. And now this material will be really simple. We are going to just multiply the particle color RGB by our texture sample RGB and connect that to the emissive color, and then our particle alpha will be also multiplied by our texture sample alpha and then connected to the opacity. And now we have our beautiful flare. There it is. Now hit apply and save, and now we need to pass this particle texture parameter to the rocket. So let's go back to our fireworks rocket and let's apply all these parameters. Back in the rocket blueprint, let's select the Niagara component, open the content browser, and drag and drop the Niagara system that we created to the Niagara system asset property. Now we can see all of our properties here, and before we change any of them or apply any in runtime, let's compile and save and see what's happening if we just test it as it is. So there's clearly something happening. Our rockets are still launching and exploding at the correct location, but our particle effects are staying here. And the reason is because we are not expecting our particles to follow the rocket and to have a velocity applied to them. So we need to create them in local space. So go to the particle system, and in the properties of the emitter, check the local space checkbox. Now we can also change the sprite material instance by default and find the material rocket that we just made and give this another go. So now it's working, but the particle is tiny, so we might want to change the default scale. Actually, I'll do that, but we'll come back to this particle system in a moment and make it a bit better. But first, let's pass all those parameters. So first, we want to see if we want this rocket to be visible. So get this boolean and branch from here. Now, if we want this rocket to be visible, first let's pass all the regular properties that are more straightforward. So drag our Niagara rocket and search for set Niagara float. Now we need 2 of these, so we can copy and paste, and don't forget to reconnect the target. When you paste it, it won't be there. And now we want to set also 2 linear colors. So set linear color, set Niagara variable linear color, and again we need 2 of these, so 1 and 2. And we'll have to set that parameter in that material parameter in a moment. But first let's do these ones. So if we select our Niagara rocket, we can see the property names. So we have our lifespan and our rocket sprite scale. So first lifespan, and next rocket sprite scale. And here we have start color and end color. Perfect. Now we can drag and drop all these variables from here. So lifespan and a scale go here and here, and then we have the start color and the end color. Excellent. Now we need to create this material instance. So search for create dynamic material instance. Now we can select the parent, which in this case we want a rocket material. And let's now pass the rocket sprite texture parameter. So we can go back to our material 1 second and copy this variable name from our texture object parameter. And now from this Niagara, first from the material instance, we want to set a texture parameter value. The parameter name is this one that we just copied, particle texture, and the value we can drag and drop our rocket sprite variable and connect it here. Now we need to assign this material to Niagara, so now we can drag and drop from the Niagara rocket component again and set Niagara material. And now we can connect the output of the create dynamic material instance to the object input on this last set Niagara variable. Now that's all if we want this rocket to be visible. And if we don't want to, we just drag in the component again and add a set visibility and set it to invisible. Perfect. Now we can collapse all this on a new function and call it set Niagara rocket properties. Now let's compile again and save and see if everything is working. So now our particle goes and disappears at the correct time. Let's say 10 rockets. Excellent. Now we can change the lifespan and see if that still stays. Perfect. And go here at the top and increase the rocket scale, let's say 10, and it goes from a blue or purple to, let's say, this green. And it's working. Now the rocket is huge, and there's a few things that we can do to improve this. First, we can do a rotation while the rocket is moving. Next, fireworks are usually not don't have a constant brightness during their trajectory, or no, it's not that constant. There's a lot of flares up and down as the gunpowder reaches like certain thresholds or certain points of the fuse, right? So let's work on that next. Back in Niagara, select the scale color, and we're going to scale this RGB. But just so we don't have to edit 3 curves manually, let's do a multiply vector by float. And in this float, we're going to select a float from curve. Now this is basically scaling the brightness of this color that we are already setting here with our lerp. So let's just for now add a few points here. I don't know, something like that. Select all of them and press 1 to give us the handles, and let's select the last one and make it end at a value of 1, and make sure that the first one is also at 1. Oh, and now we can, maybe this one goes to almost 0, then it goes to 3, then it goes to almost 0 again, and then goes to, I don't know, maybe just 2, and then a bit less than 1, and then a bit more than 1, and then 1, and it ends. Cool. So now let's save and see how it looks. Yeah, now it blinks a little bit up and down. That doesn't look too bad. Now on the particle update stage, let's also add a sprite scale. Scale sprite size, and just change it to maybe a smooth ramp down, and move the first point to maybe like 0.5 or something like that, so it only starts getting smaller in size close to the ending. Yeah, something like that. Oh. Yeah, doesn't look too bad. Now we are going to do the rotation, but okay, for something like that, let's say let's add a sprite rotation rate first. So a sprite rotation rate module, and let's say a value random float between -500 and 500. I'm like, oh, it doesn't look too bad. It's not too bad. Yeah, it could work, especially from a distance. It just adds a little movement. Great. But now let's say that you want to use something like this other texture. So let's select our Flair 3. Now for something like this, it doesn't look too great if it's rotating. Let's check it out. But yeah, probably something like that, you just want to be flat all the time. So let's make the rotation a Boolean parameter that we can change. Actually, I'm going to change this back to the flair 2. Apply and save. And here in Niagara, let's add a new Boolean value or user parameter. And we can call this one, oh, I already created it, random sprite rotation. Yeah, it's here. Perfect. So now on the sprite rotation rate, instead of just a random range float, let's do a multiply float. And our first parameter is going to be back to be a random range float. And again, I think minus 500 to 500 is not a bad range. But then for B, let's search for bool and select make custom float from bool. Now we need to drag our user parameter here to link it. And our true float equals 1 and false float equals 0. That's correct. Now if we press play, now it's not rotating, but if we check this value, now it's rotating. Excellent. Now we can save, and we need to add this new Boolean to both our fireworks launcher and the rocket. So let's start with the rocket. Let's add a new Boolean and call it random sprite rotation. We can move it to the correct category. And then now that we're here, actually on this set Niagara rocket properties, let's also add it here. So set Niagara bool. So set Niagara variable bool. And connect our random sprite rotation property. And we need to rename the component or the node here. So this will be our random sprite rotation. And this will be also our sprite material inst. Excellent. Now this variable needs to be, again, as all the others in the fireworks rocket blueprint, needs to be public and exposed on spawn. And now, as always, we'll need to go back and forth between the launcher and the rocket a couple times and compile before this appears here. But now we can add it, random sprite rotation, move it to the correct category and connect it to this input. And now let's compile and save and see if everything is working. So our launcher works. Let's again make it a bit slow. Let's say 500. Shoot one rocket. It's not rotating. And oh, I didn't make that variable public. So let me go back here 1 second, and on the launcher, random sprite rotation, make it visible. And back. Again, let's make the rocket really slow and shoot one. And it's not rotating. Now it is. And we can change the color from purple to cyan. Make it a bit bigger and change it to the flair 3. And now disable the rotation. Yeah. And now it's working. Perfect. Next, let's start adding some trails. To configure our trails, we're going to do things a little bit differently. You see, up until now, we've been passing our parameters to the rocket and launcher blueprints individually, because we were only using them once and we only had a few. Now for the trails, I want to be able to stack them. For example, I might want to have a smoke trail and also one or two types of sparks. And to do that, we need to pass the parameters in a group. And we'll do that using a structure. So on the content browser, right click on it, and in the blueprint category, select a structure. And let's call this one Fireworks Trail Settings. Now the first element of this configuration is going to be the type of trail that we want to apply. And we could expose the Niagara system asset and just let the designer choose one, but we want to make this launcher very usable, and it will be easier to select a type of trail if you just had something like smoke or sparks or something like that. And we can do that using an enumeration. So right click again, and again in the blueprint category select enumeration, and let's call this one a Fireworks Trail type. Now let's open the enum first. And this is just a collection of strings, so we don't need to set the type or default values. And we can call this one first, maybe something like simple sparks. The second one is going to be smoke, and maybe on the tutorial we'll do a third one, maybe something like a spiral. We might add more trail types in future videos, but 3 for now will be okay. Now save this, and now open the content browser again, and let's go to our trail settings. Now this by default has a boolean, so let's change the type of this to our new enum. So Fireworks Trail type, and because we already know that this is a trail settings structure, we don't need to call this one trail type. We can just call this one type. And we need a few floats now. So first we need maybe like density scale, then length, and maybe also just a sprite. A sprite scale. Finally, I'll do just one first. We'll need a couple of linear colors. So let's do a start color, and you guessed it, end color. And now we can save this, close both the structure and the enum, and start using all this new stuff. First, in our Fireworks rocket, let's create a new variable and call this one Trail Effects, and search for our new structure. So Fireworks Trail Settings. Perfect. Now we need to make this public and also expose on spawn. And right click on the little color icon, a little blue nib. So it changes to this 3x3 grid, which represents that this variable is now an array. And we can move this to the trail settings category. Now we need to add this to our Fireworks launcher, so we can go back and forth. Now it's here, and let's add this same variable. So trail effects, change it to our trail settings variable type, and right click on it to make it an array. Now we can compile and drag this and connect it to the trail effects. Now let's give this some default value, and we'll start with the simple, maybe like the sparks first. So let's keep it as simple as sparks. Actually, we can delete this and change the default values on the structure. So open the structure and go to the default values tab, and let's keep density, length, and sprite scale at 1 by default, and put some colors, something bright like maybe this red to blue, and save. And now we can add elements to this array. Oh, we didn't save this or compile. Oh, let's see if this works now with the default values. Perfect. Now we don't need to change this. So let's make this simple sparks effect before we actually spawn it. So the content browser, let's go to the Niagara folder and let's keep things a bit organized and create a new folder here for trails. And now a new Niagara system. And let's select for this one maybe the fountain as a template. Click the plus icon, finish, and call this one Niagara system simple, or maybe first trail simple sparks. Excellent. Now we can open it up. Oh, there we go. And start making some changes. Let's start by bringing in our variables. We'll need a few floats. So this will be the trail, density scale. Then another float will be the sprite scale. And finally, we'll need the trail length scale. Cool. Now we need another float because we're going to also bring in the duration of the whole trail. We'll see how to use that in a moment. So trail duration. And now we need both of our linear colors, star color and end color. Now let's keep all of our scales at 1 for now, and the duration, let's say 2 seconds. And now we can select a couple of colors for start and end. And now let's save and let's use all that. As I mentioned in the previous chapter of this series, one of the advantages of using this method is that we can combine CPU and GPU emitters with no problem. So let's make this one a GPU sim actually. And we can give it fixed bounds. And let's change the spawn rate for something, first for a multiply float. And let's say something like 5,000 times our trail density scale. Cool. Now we'll have more particles if we have a higher density. Excellent. Now on the lifetime mode, let's keep it at, let's say, direct set and change it for a multiply float. Now the first one will be our trail length scale, and our second one, let's do a random range float. These particles or these trails are usually very short-lived, so let's say 0.1 to 0.4. Cool. Now we want to change the shape location. It's a sphere. Let's make it just a bit smaller, maybe like 5. And instead of adding velocity in a cone, let's add the velocity from point. And let's make it a lot slower, maybe like from 5 to 10. The trail effect will be because we have particles emitting from different points, not because the particles are very fast. And this increasing this value basically will give your particles more of a cone shaped distribution as the rocket flies, or they will keep like more of a line. And let's see, gravity is okay. We can increase the drag, maybe like 2. And now for the color, let's do something similar to what we did with the rocket. So we can change, when we emit these particles, we'll set the initial color as lerp. Oh. lerp linear colors. And we'll say from the start color to the end color. And for the lerp factor, let's do an expression. And we can do emitter dot age divided by user dot, let's go, trail duration. Perfect. Now particles start in one color, and a couple of seconds later they change into a different color. Cool. Now finally we want to change also the sprite size mode. So let's also set it to uniform, but then change it to a random scale by our parameter. So we need a multiply float, and then again, the first parameter we can just drag and drop our sprite scale, and our second, let's do a random range float between, let's say this, I want these particles to be pretty small, so maybe like 0.25 to 0.5. And I think, yeah, I think that's not too bad. Now we can keep this scale color so the particles just fade as they disappear. We could make them smaller, but they are pretty tiny. And we could also orient them in the direction they're moving, but for these particles they're actually not moving very fast, so it's probably fine with these settings. I think maybe add a curl noise, pretty strong, like maybe 1,000, and with increased frequency. Yeah. And let's make it move. So maybe minus 0.3, 0.26, and minus 0.53. Cool. And let's now attach this effect to our rockets. Let's compile and save, and we can go to our rocket. Actually, as Colombo would say, just one more little thing. Let's go back to our particle sparks, our trail simple sparks effect, and in the scale color, let's scale this RGB. And similarly to what we did with the rocket, let's multiply our vector by a float. Keep this one as 1, and in the float, let's change this from for a float from curve. Because we're changing the particles color here, based on the emitter age divided by the duration, so they change color over the entire duration of the rocket. But each particle, I think that right when it's emitted, it's very bright, and then it loses brightness. So we'll do that with a scale color, and we can just like maybe let the pulse out template and change this to be a 1, this to be a 2, and this back to be a 1. Yeah, so the core, as the particles are being emitted, is a bit brighter, and we could even scale this brightness a bit more, maybe like 5. Yeah. Or even have an exposed parameter that was trail brightness scale and just apply here on this scale curve. But for now, I think this will be enough. Now we can go back to our rocket and start creating all these Niagara systems. That will be here on the event begin play. So as the rocket starts existing, let's create a new function and call it set Niagara trails. And we're going to call this function right after we begin play. Let's get our trail effects. And for each one of these, so let's get a for each loop. Let's take our array element and break this into its different components. So let's switch on the different types. And let's say if it's a simple sparks, we could also create like a temporary variable with just, actually let's do that. Let's create a temp Niagara asset on the local variables area and change this for a Niagara system and object reference. And we need to change here again to a normal variable and not an array. And now let's change this to a set this, and we can select our sparks, which it's called trail simple sparks. There we go. Now after this we can spawn a system attach, and the system that we want to spawn will be the one that we just set here. Actually, let's just grab this and connect it like this instead. It will be a bit cleaner. And let's see what else. We need also to attach it to a component, so let's attach it to a collider. Perfect. And the location is going to be 0, and that's it. Now actually we can promote this to our local variable and change this to maybe trail ref for trail reference, so we don't need to drag always from here. And now let's set all our properties that we can just create it here. So let's set trail duration, length scale, sprite, and density scale. Maybe the first one we can do it from here. Set Niagara variable float, and this will be our trail duration. And this one is in our rocket lifespan. Next, let's grab a trail reference, and we want to set another float. Copy this a couple times. And we want our trail sprite scale. Trail length scale. And finally, at least for our floats, our trail I did length and sprite and density, then density scale. I typed the word destiny a lot at work, so between density and destiny I keep always messing things up. So now we have all of these properties here defined in our fireworks trail settings or in the array element. So this one would be our density scale, and that's here. Then we have our length here, and we have our sprite scale here. Now let's double click on this to make things a bit neater. And easier to read. Actually, let's lower this down and then lower this 3 down as well. Now it should be a bit easier on the eyes. Perfect. So now for each one of these ray elements, which is each one of our trail effects, will determine, depending on the type of effect that we want to create, we set the different asset, Niagara asset that we want to use, and then we spawn it and set all its properties. Now let's do the colors too. So let's get this and set linear color, and we need 2 of these. And they will be our start and end color respectively. We can again do the same, drag them from here. First the start, double click, create a reroute node, and then the end, do the same here. And there is way nicer ways of organizing these. We could always promote this to a local variable as well and use this reference instead of just these long spaghettis around, but I think that's gonna be okay. So now we're doing this, and I think we're ready to give it a go. If we want to change the settings, we'll need to make these trail effects visible on the launcher, and then we can move them maybe to the rocket settings. Now we're ready to give this a go, and you'll see that there's an issue here. Might be hard to see, so let's go to our rocket settings and expand the trail effects, and let's change this one to, let's make it 5 times as dense and 2 times as long, and the sprite let's make it also like huge. And yeah, there it goes. And I don't know if you caught that, but after it exploded, it kept going. So we need to deactivate the trail after the explosion. Now there's a couple ways to do that. We could deactivate it on the Niagara effect directly, because we know the duration of this trail, so we could set the emitter age or the emitter loop duration to that, or we can just deactivate it on the blueprint. Let's do that. Let's go to our blueprint and let's find our rocket, and let's go to the event graph. Now, here we actually don't need this set visibility anymore because our collider is not visible, but we have this is trail active here. So now let's create a new function and call it deactivate trails. Deactivate trails. Now here's an issue though. We don't know which trails need to be deactivated. So we need to go back to our set Niagara trails and do one more thing. So after each time that we create one of these trails and set all the properties, we need to add this trail reference to a list. So we have a list of trails to deactivate later on in this new function. So let's create a new variable that will be here, will be public, and I mean not public, will be on the class level, not local. And let's call this one trail references. Perfect. And we need to change this one for an array. And we can grab now one copy, get, and then get also a copy of our trail reference. and we need to add an element to this array. So add, and then we need to add. Oh, sorry, it's a Niagara system. No, it's a Niagara system component reference. Let's grab our variable again and connect it, and then now we can connect our reference. Yeah, so make sure that this is a Niagara particle system component array, because we're creating Niagara system components here. And that's it. Now we can compile and save and go to our deactivate trails. And this one will be pretty simple. We just need to get our new array, and for each one of those we can drag from the array element and search for deactivate. Now back in our event graph, so our function is just deactivating each element in this array, and back in our event graph we can drag a copy of our function and reconnect it as it was before. So we are setting this property to false and then deactivating our trails. Let's see if that works. And let's make this very visible. So 2, 2, 5, shoot rocket, and the trail stops being emitted right after it explodes. And the colors change over the time, not the colors that are already emitted, so we get this nice gradient as the rocket flies. And I think we're ready to make another couple types of trails. Let's start with the spiral, actually, because it's going to be easier and very similar to our current trail. So let's get to our content browser and let's make a copy of our simple sparks. So right click on it and click on duplicate, and let's call this one trail spiral. Now, since we are gonna use the same parameters, we can keep a lot of the stuff the same, but we're going to maybe reduce the gravity to just a little bit, like -50 or something like that, and reduce the drag maybe a little bit. But the main thing is we're going to change how we do the velocity. So instead of from point, let's do linear. And instead of specifying a vector like that, we're going to make our own vector. Now, all this would be easier probably with an expression, but let's do it like this. On the x-axis, we're going to do a sine. And on the y-axis, let's do a cosine. And finally, for z, let's do just a little bit of vertical velocity, maybe like -0.1. Perfect. Now let's make this very fast. So maybe 0.0 or 0.75 on both x and y. And let's see what happens. It's hard to see because, well, right now our velocity is very small. So let's increase this by about 500. And now we can already get an idea of what's gonna happen. And there we have it, a beautiful spiral. Oh, let's apply this to our rocket. So we can now close this one and close this one, go to our rocket and go to our set Niagara Trails function. And the only thing that we need to change, and that's the advantage of this method, is that we just need to change this set here. So we can copy and paste it. And if we're doing a spiral, let's search for The same Niagara system trail. Oh. Spiral. Oh. There we go. And this is the one from the tutorial. And now we can copy or connect it to the same spawn system attached node. So let's move all this part up a little bit, so we have a bit more room. Let's compile and save, and let's actually try combining these two. So we can go to our fireworks launcher, and here on the trail effects we have these simple sparks. Let's add a new element, and on this one we're going to select a spiral, and let's make it from green to maybe an orange. And let's change the scale and length and density, just so it's easier to see. Actually, let's make this really big. Cool. Now we can change maybe the scale to be less, and maybe the length on this one to be a bit higher. And now we can combine our different effects to produce a lot of different variations. And now we have only two trails. We can always combine more and more on a single launcher. Actually, let me open our spiral. I think maybe I want them to leave a little less on average, maybe 0.1 to 0.2. Let's see how that looks. We can just select this one and change the type, and let's do a bunch of rockets. Let's do 15 rockets. Oh, so there they are, our spirals. We could change always more parameters here, so we could make them change slower over time, or rotate slower over time, and produce less revolutions on the spiral by changing this period. And we can make the radius of the spiral bigger or smaller by changing this speed scale here. But I think for now it's probably good enough, and we can move on to the smoke one. We are going to need a new material for our smoke trail, so I already went ahead and created that. And since it's almost the same that I used on the lighting VFX tutorial, I won't go into all of the details. We have a texture sample that is a scale 8 times, sampling the soft smoke texture. And here we have a particle sub UV sampling the smoke sub UV 8x8. Both values are added, then multiplied by the particle color. And that's the base color, not the emissive. And then the alpha of this particle sub UV is multiplied by the alpha of the particle, and then passed as the opacity. Now, as for the material parameters, we have surface, translucent, and the fall lit is two-sided. And if you search for Niagara, it's marked to be used with Niagara sprites. Now, the other thing that I did, if you scroll down a little bit to the translucency settings, I changed the lighting mode to volumetric non-directional, since I'm not using normal maps. If I was, then I would change it to volumetric directional. And now we can save this and close it. Now we can go ahead and in the content browser, let's go to our trails folder and duplicate our simple sparks one more time, and call this one trail smoke. Now on this one, we can reduce the spawn rate probably a bit. We don't need that many particles, let's say 1,000. And in the initialized particle, we can make this live a bit longer, like maybe from 0.8
to 1.2, and let's make these ones really big, like 25 to 50, or even bigger, like 50 to 75. Now we don't need the velocity, so we can get rid of that. And let's see, gravity is fine. Drag, maybe we want to increase quite a bit, maybe 10. Scale color, we can keep the scale alpha, but we don't need to scale the RGB. The brightness of the smoke is not going to change over time. Next, on the curl noise, we can just have this and also have the frequency. And let's see. Okay, this is a lot more subtle and slower movement, but we need to scale these sprites, so scale the sprite size, and let's make it a smooth ramp up. We want our smoke to grow as it fades. Cool. Now we need to use all these new materials. So get to the content browser and drag our lead smoke to our sprite material. And next we need to activate the sub UV, or increase this size to the correct size, which is in our case 8x8, and maybe check this box to blend between different frames. Now we need to animate those frames, otherwise all of our pieces of smoke will have the same frame, and that's here on the particle update. We can search for sub UV and add a sub UV animation. Here we need to select the sprite renderer and maybe just check the random start frame. And now as our particles move forward in time, they change the current frame. So our clouds change a little bit. Now I think that should be it. And let's save and go back to our fireworks rocket so we can add the new asset. So we can copy paste this, connect it on both sides. Actually, let's just make this organized and replace the asset here on the one connected to the smoke to our new trail smoke. Now we can compile and save and see how it looks. Select our fireworks launcher and let's add a new trail effect and set it to the smoke. Maybe just to make sure that we see it, let's make it even double the size and 1.5 times the length, and just change it to white. And there it is. Right now it's really big. I made it intentionally too large, but that will be used to show one of the things that I want to change next. So let's shoot a bunch of rockets at the same time. Let's say 25. And click shoot rockets, and off they go. Now, new rockets are not, or rockets currently are not casting any light. Right? They have this flare effect and this lens dirt. That's just a post process that takes the illuminance of the pixel, right? So it's not really casting any light on the smoke, but we made the smoke use directional light or non-directional lighting, so we should be able to add a light to these rockets. And the way to do it will be, instead of spawning a new rocket or new point light component, we're just going to add a light renderer to our rocket system. Oh, sorry, not to this one, to the Niagara system. So go to Niagara folder and this Niagara system rocket, where we're just spawning this flare. We're going to add a light renderer. So light renderer, and we'll need to change some of these parameters to make it look right. Now, when we use a light renderer in Niagara, our particles will emit light in the scene. The color and brightness of those lights is determined by the color and brightness of each particle. And now we can disable the use inverse square follow
which controls how the brightness fades over distance, and everything will be easier to configure if we just uncheck this. Next, we want mostly to illuminate our smoke, and our smoke is translucent, so we need to check the affects translucency property. Note that there is a warning about carefully using this property. Now, if you have a ton of lights and all of them affect translucency, performance is heavily impacted. For one particle, like we use in this case, it's not that big of a deal. Now we can check the alpha scale's brightness to scale the brightness of the light based on the alpha of the particle. And now let's set this radius scale to maybe 1 or 2 units, a very small radius, and increase the default exponent quite a bit. Now the inverse square fall-off, as the name implies, is just the exponent of 2. So let's set maybe 16 or 32. And this should be fine. Now I already changed my blueprint, my launcher blueprint on the scene to have smoke, and I also set the smoke color to be white but with a 0.5 alpha. We probably will never want a smoke to be fully opaque. Now let's give it a go and select our launcher and shoot some rockets. Now let me pause this. Now, as we can see, each particle is creating some color and emitting some light that illuminates the smoke, usually of previous trails that had time to expand and grow a little bit. And that will make your effect come alive a lot better and have a lot more color, especially when you're shooting multiple rockets at once. And I think that this has probably been enough information for one video. Today we did a lot. First we added a visible effect to our rocket fireworks object, and then we made a system that allows us to combine multiple trail effects together. As you can see here, you can already get pretty cool looking variants using just the 3 simple trail types that we made and some parameter tweaks. In the next chapter, we will finish version 1.0 of this fireworks system by implementing a similar method to layer up explosion effects and some other details. Until then, check out other tutorials from the channel, and if you like this content and want to see more like it, please consider subscribing and hitting those like and notification buttons. See you next time!